Hi everyone, in this video we are going to be looking at limits. So this is the beginning of our limits unit. And we've talked about limits a little bit already, but now we're going to get deeper into the concept of a limit. So I'm going to start off with just giving you the definition of a limit. Alright, so the definition is if f of x becomes arbitrarily close to a unique number L as x approaches C from either side, then the limit of f of x as x approaches C is L. Okay, the way that we would write that out is the limit as x approaches C of f of x, so whatever the function is, equals L, whatever the limit is. Okay, and we've seen this already before. We've just seen the C as infinity, and we were dealing with infinite sequences and series. So it is something that we are a bit familiar with. Something you should know is that the function does not have to be continuous at C, so it could be discontinuous, and we'll see a few examples of that. The purpose of this video, I'm going to show you two different methods on finding limits. One will be using tables, and that's what we called numerically, and two will be using algebra techniques, and that's what we call finding a limit algebraically. There is one other method we could use to find limits, and that is graphically, but we're not going to do that in this video today. Okay, so the first example I'm going to do is estimating a limit numerically or using a table. So finding limit numerically using a table. So you're definitely going to need your graphing calculator for this, because we're going to be plugging in numbers that are very, very close to the number we are trying to approach, the number that x is trying to approach really in the function. So here's the example. We are trying to find the limit as x approaches 0 of x divided by the square root of x plus 1 minus 1. Okay, so we are trying to figure out what happens to the function as we get closer and closer to 0 from both directions. Now, what both directions means is that we're going to be looking at the left, or numbers smaller than 0, and then from the right, numbers bigger than 0. But still, they're going to get really, really, really close to 0. And the way that we're going to do this is making a table. So I'm going to start off with 0 in the middle of my table. So this is x, this is f of x. 0 is going to be in the middle. 0 is what I'm trying to approach. You will notice that I don't know what happens at 0 exactly, because I can't really plug in 0 here. Right? If I plug in 0 in that denominator, 0 plus 1 will be 1, square root of 1 is 1, 1 minus 1 is 0, and I'm going to get something undefined. But that doesn't mean that there isn't a limit. So this is what I was talking about, that you don't have to be continuous at that point. So in this graph, and we'll talk about graphs later, like I said, there might be some kind of hole or asymptote at 0, something like that. All right, so I'm going to get closer and closer to 0 on both sides. So I'm going to start off here as negative 0.01 for x. Then I want to get even closer, so I'll do negative 0.001. Then I want to get even closer than that, negative 0.0001. Okay, so you see I'm getting very, very, very close to 0. From the other side, I'm going to do the same thing, but I'm going to be positive. So it's going to be 0.01, 0.001, okay, and 0.0001. Okay, so as you can see, these numbers are really getting close to 0. What we're going to do with these numbers is we're going to plug them in, and we're just going to use our calculator for that. Or you can actually make a table on your calculator. It's up to you. So if I want to plug in, let's say the first one, I'm going to, on my calculator, do negative 0.01 divided by the square root of negative 0.01 plus 1, square root of that, minus 1. If you do that on your calculator, you're going to get 1.99499. Okay, and you would plug in all of these that same way, do it on your calculator. The second one I get 1.99949. The next one I get 1.99995. 0 I don't plug in, like I said before, it is undefined. Okay, and then the other direction for the first one here, I get 2.00005 when I plug in. Then the next one I get 2.0005, and then this one I get 2.00499. Okay, it becomes pretty apparent that from both directions, as the function approaches 0, I get very, very, very close to 2. Okay, so that's how I would use a table. Tables really are not the preferred method, but I needed to show it to you. It is a method, and it does work, but you know, we don't really want to plug in that many numbers. We want to make sure for sure we're getting the right thing. So algebraic methods are more traditional and graphing methods are more traditional. But we do have the table, we do need to know how to use it, and that's exactly what we would do with it. All right, so that's our numerically finding limits example. All right. In terms of algebra techniques, we have 4 solid techniques that we typically use. The first one is just direct substitution. So you can use direct substitution anytime that the function is continuous. So this is going to be our first algebra technique. Okay, so this is called direct substitution. All right, let's say I had the limit as x approaches 0 of x squared plus x minus 6 over x plus 3. Okay, direct substitution is exactly what you think it is. You literally just substitute in the value. I'm allowed to substitute in the value here because it's defined at 0. All right, so I am allowed just to plug in 0, so this is going to equal 0 squared plus 0 minus 6 over 0 plus 3, which is just negative 6 over 3, negative 2. So the limit of this function as x approaches 0 is just negative 2. Now this is not always going to be the technique, okay? You might have this like same format, but you might have a value that you can't really plug in because there's some kind of issue that makes the denominator 0 or something like that. So in that case, you might have to use factoring. Okay. All right. So using factoring would be like if I wanted to find the limit as x approaches negative 3 of x squared plus x minus 6 over x plus 3. So the same function, but now there's an issue because if I plugged in negative 3, my denominator will be undefined. It would be 0, so the whole function would be undefined is what I mean. So in order to do this, we're going to have to factor the numerator and see if anything could divide out. All right, so I'm going to change this to the limit as x approaches negative 3. Numerator is going to be x minus 2 times x plus 3. So that's what the numerator factors into, and then I still have over x plus 3. And then we see that these two could go away, right? They become 1. And then you have the limit as x approaches negative 3 of just x minus 2. And because it's continuous now at that value, I can just plug in. So this is going to equal just negative 3 minus 2 or 5. So, sorry, negative 5. Negative 5 is our answer here. So that is the limit. Okay, so that's one technique. Sometimes we could also just simplify, like sometimes you can just simplify something in the numerator and whatever the value is, we could plug in afterwards. That's not as common as factoring, but it still holds true. Like that still might happen, that you just simplify. Another technique that's pretty useful is rationalizing. So I'm going to show you that now on the next slide. Okay, so this would be the third pretty common technique, rationalizing. All right, so let's say we had the limit as x approaches 0 of the square root of x plus 1 minus 1 over x. So we do see an issue, right? You can't plug in 0 into that denominator, it'll be undefined. So can't do that. So instead, we're going to try to rewrite this function by rationalizing the numerator in this case, because that's where the square root is. So we are going to multiply by the conjugate of the numerator. And it's going to keep the equivalency to what we have now. So we always do have to keep it equivalent. But we might get a form that becomes something that we could plug into. All right. So I do have to FOIL the numerator. Okay, and when I FOIL it, I get the limit as x approaches 0. My new numerator, I'm going to have x, the square root of x plus 1 times the square root of x plus 1. That's just x plus 1. Okay, then x, the square root of x plus 1 times 1, and negative 1 times the square root of x plus 1, those are going to cancel, right? They become opposites. And then I'm just left with the minus 1 when I do this one. Okay, over the denominator, I'm just going to write it as x times the quantity square root of x plus 1 plus 1 for now. Okay, so what happens here now is that the numerator further simplifies. The numerator I can write as just x, because I have x plus 1 minus 1. Okay, and then I see I have an x over x, which is just 1. So now I have the limit as x approaches 0 of 1 over the square root of x plus 1, which is something that now I can just plug into. So when I plug in here, I'm going to have 1 over square root of 0 plus 1, which is 1 over square root of 1 plus 1, which is 1 over 2. So the limit as x approaches 0 of this function is 1/2. And we just use the rationalizing technique. Okay. Another pretty common technique is common denominators. So I'm going to show you the last example here with that. Okay, so this one we're going to have the limit as x approaches 0 of 1 over x plus 1 minus 1 all over x. Okay, so issue here, once again, I can't plug in 0 because the denominator of the entire fraction would become 0. Okay, so I'm going to find a common denominator for the numerator. That common denominator is going to be x plus 1, so I'm going to change the 1 here to be x plus 1 over x plus 1. Okay, denominator still x. Alright, so now I am going to do some simplifying in my numerator. This negative has to apply to both, and I'm going to make it one fraction. So I'm going to have 1 minus x minus 1 over x plus 1. So that's the numerator, all over x. Okay, I'm going to come up here now. So now I have the limit as x approaches 0. Continue simplifying the numerator, and I have negative x over x plus 1 all over x. Okay, there's still some simplifying that could be done here. I have a fraction being divided by essentially a fraction because this is really over 1. So I'm going to do that work here. It's going to be negative x over x plus 1 times 1 over x. Okay, and now I see that this and this become negative 1. So now I have the limit as x approaches 0 of negative 1 over x plus 1. Okay, and now I could just plug in 0 and I get negative 1 over 0 plus 1, which is negative 1 over 1 or negative 1. So the limit of this function as x approaches 0 is negative 1. And that's pretty much the last real technique. Everything else will just be like simplifying or different types of factoring. That's pretty much all the algebra techniques, and you're going to want to do this whenever you can't directly substitute. Alright, all these values are going to give us what the function approaches as it approaches that c value. Okay. We do know even from what we looked at with sequences and series that sometimes limits don't exist. Sometimes limits are infinite, right? They go to infinity or negative infinity. We're going to get more in depth with that and when limits don't exist. For now, we're just looking at how to do it numerically using tables and how to find them algebraically using algebra techniques. All right. And that's it for this video on limits. Thanks for watching.